Hey guys, welcome to the notes for X and Y intercepts. We are in Unit 3A. Our essential question is, what is the process for solving for an intercept? So we have some vocabulary review. We have x-intercept and y-intercept. So that's just the entire notes you're going to entail just x-intercepts and y-intercepts. Okay, so an x-intercept, just as review, is where the line crosses the x-axis. Now, I'm calling it a line because Unit 3 is all about lines, so I'm okay with saying that it crosses the x-axis and calling it a line. But when we're talking about quadratics, that's not necessarily a line. It's just, a parabola, a quadratic. So it's where the line crosses the x-axis. And y-intercept is where the line crosses the y-axis. Okay, so down here I have 4 graphs, and we're going to identify the x and the y-intercepts. So label the x and y-intercepts for each graph. I'm going to start on this first graph. Now, when we're talking about ordered pairs or coordinate points on a graph, we always want to write it as a point. And points are written x, y. So you always want to move in the x direction, so left or right, and then you want to move up or down in the y direction. So when I'm looking at my x-intercept, I'm looking where my line crosses the x-axis. The x-axis is here, and the point that crosses the x-axis is at, well, you want to go positive 2 to the right, so 2, and then you're not moving up or down, so it'd be 2, 0. The y-intercept would be, well, I can't move left or right any, but starting at 0, 0, I go up 3. So I have 0, because I don't move left or right, and then I have 3. So you start at 0, 0, and you can figure out where your points are going. Okay? On this next graph, I didn't do that. Okay, back over here, or to the next one. At the x-intercept, we're looking at where it crosses on the x-axis. Again, you're moving positive 4 to the right, in the right direction, so it's positive. And then you're not moving up or down any, so you're going to have 0 at our x-axis here, or our x-intercept. The y-intercept is on the y-axis, and we're not moving left or right anywhere if we start at 0, 0. So it would be 0, and then we would go down 2, which gives us negative 2. So we have a y-intercept of 0, negative 2. All right, the next graph, we have a horizontal line, which if you didn't know, it has a slope of 0, just for fun, right? A horizontal line has a slope of 0. And then I ask you, are there any x-intercepts? No, because it's never going to cross the x-axis. So for this, you would say none, that there aren't any x-intercepts. But we do have a y-intercept. It intercepts the y-axis at this point here, which is the point 0, negative 3. Okay? And in the last graph, do we have any x-intercepts? Yes, it does cross the x-axis at one point, at the point negative 2, 0. So you want to move to the left negative 2, and then you don't move any up or down, so you have 0. And then it never crosses your y-axis, so you have no y-intercepts, so none. Okay? You don't want to leave it blank, and you don't want to say 0, 0, because 0, 0 is saying that it does cross because it crosses at the point 0, 0. So it doesn't actually cross there, so you don't want to put 0, 0 if it's none. You want to just say none. Okay, so I want you to look at all of your x-intercepts, just all of the ones that we wrote in red. And I know one of them doesn't have one, but look at all of the ones that we wrote in red. What do you notice about all of these that they have in common? So looking at the x-intercepts, what do they have in common? Well, the thing that they have in common is that all of the y values are zeros, right? They're all zeros for the y values. So there's some number in the x value, and then there's a 0 in the y value. So they all have the form a number and then a 0, right? What do you notice about all of your y-intercepts? Well, all of the y-intercepts have a 0 in for the x value. So 0, number. So if I ask you what an x-intercept looks like or what the form is, you say x, or x, 0, or you can say number, 0. For the y-intercepts, they all have the form 0, number. Do you see that? Do we see how all of the red have all the zeros for the y and all the green have a 0 for the x? So, just reiterating, an x-intercept has a number in the x spot. We're solving for x. A y-intercept has a number in for the y spot. We're solving for y. So it tells you where your number is supposed to be. So an x-intercept, the number should be in the x spot, and then you have a 0. For a y-intercept, you have a number in for the y spot, and you have a 0 for x. So now we're going to use this with some tables. So now we've looked at some graphs. We're going to look at some tables now. So identify the x and y intercepts for each table. And just a reminder from the last page, x-intercepts look like what? Number, comma, 0. Y-intercepts look like 0, comma, number. The only way to mess this up is that you forget which one of these has what form, okay? So, looking at the first table, the one on the right here, on the left, I'm sorry, the one on the left, you want to look for the x and y intercepts, and you're given two columns, an x column and a y column. And remember, tables are just a way to write points. So you're looking first for an x-intercept. You're looking for something that has a number in the x column and then a y in the, or a 0 in the y column. So if I look, I notice that I have 2, 0 here. Do you see that? I have a number in the x column and I have a 0 in for the y column. It has this form. It looks like that. So my x-intercept here would be 2, 0. My y-intercept has to have the form 0, number. So I'm looking for a 0 for the x and then a number for the y, which is going to be this one, 0, y, or 0, 5. Do you see that? It has the same form. Okay, now this table is a little bit different. It doesn't tell you where your x values or your y values are, but you always want to make sure and you always assume that the x is always on the left. So I'm going to put imaginary x there because they didn't give it to us, but I know it's supposed to be an x. And I know that that right one is supposed to be y. So I have x and y there. Okay, now I'm going to look for my x-intercept. Remember, an x-intercept has a number first and then a 0. So you can't just pick any point. You have to pick the x-intercept. Well, the number first and then a 0 for the y is going to be -5, 0. And then the y-intercept is where I have a 0, comma, a number. And that's going to be 0, -3. Okay? Same thing here. I'm identifying the x and y intercept. I'm looking for number, comma, 0 for the x-intercept. Now this table is a little bit different because it's sideways. So you have to think about your x values are up at the top and your y values are at the bottom. So your x-intercept here would be number and then a 0, which is going to be 4, 0. And then my y-intercept is always going to be 0, comma, number. And so that's going to be 0, comma, 1.5. Okay? And if I look and I want to double check all of my work, do you see how all of the x-intercepts, they have number, comma, 0? And then all of my y-intercepts have 0, comma, number. So you always want to make sure that your zeros are in the right place and you know what you're doing. Again, the only way to mess this up is if you just forget what an x and a y-intercept look like. Okay. Next, we're going to calculate the x and y intercepts. So we have 4 problems we're going to calculate the x and y intercepts. And just a reminder, an x-intercept looks like number, comma, 0. Okay, the number goes in for the x. You're solving for x. And then the y-intercept is 0, comma, number. So it's always a 0 in for the x value, and then there's always some other number over there. Okay, so starting with number 1, I have 2x plus 3y equals 12. This is a linear equation. It is a line. And I want to solve for its x and y intercepts. The first thing I'm going to do is I'm going to first divide up my workspace. I'm going to give one section for the x-intercept and one section for the y-intercept. So I'm going to draw a line down the middle here for number 1. And on the first side, on the left side, I'm going to write x-intercept. I'm going to find my x-intercept on this side. Okay? Now, what does an x-intercept look like again? It's number, comma, 0. But do I know what that number is for this problem? I don't. So I'm going to put blank, comma, 0. I'm solving for that blank. I don't know what's in that blank. Now, again, I'm solving for the x-intercept. I'm sorry, I'm trying to change colors. So the first thing I'm going to do is I'm going to write that equation down again. 2x plus 3y equals 12. I'm going to write this down again. Well, what's my next step here? Well, I know an x-intercept always has a 0 in for what? It always has a 0 in for y. No matter what an x-intercept is, it is number, comma, 0. And the 0 is always in for y. So I'm going to plug in that 0 for the y value. So I'll have 2x plus 3 times 0, because anytime I plug in, I always want to use parentheses, equals 12. So what did I do here? I took the 0 that was my y value and plugged it in for the y value of 0 for my equation. Okay, well, 3 times 0 is 0, right? It goes away, so it cancels. And then I just have 2x equals 12. And then I solve for x. Why am I solving for x? Because it's an x-intercept. I'm solving for it. So I have divide by 2, and I get x equals 6. Now, is that how I write an x-intercept? No. You write an x-intercept as a point. So our x-intercept is 6, 0. Okay? Not too bad, right? So that's why we're calling it an x-intercept. We're solving for the x value. We know what the y value is. We know it is 0, and we're solving for x. Now I'm going to do the same thing, but with the y-intercept. I have 0, number, right? I have 0, blank. I don't know what that number is yet, so I'm going to solve for it. The first thing I'm going to do is I'm going to write down that equation again from the beginning. Now what do I do this time? Well, this time I'm going to plug in a 0 for x, because that's where the x value is, and the x value is 0. And I know it's going to be 0 because a y-intercept always has an x value of a 0. So I have 2 times x, which is, I always put in parentheses, plus 3y equals 12. 2 times 0 is 0, so that cancels. It just becomes 0. 3y equals 12. And then you divide both sides by 3. And y equals 4. Is that my answer? No, because that's not how I write a y-intercept. A y-intercept is 0, number. And I've solved for that y value, so my y-intercept is 0, 4. Okay? Now, if I were to go into Desmos and graph this, it would show me those x-intercepts and that y-intercept. So let me go into Desmos really quick. So I have, I believe, is it 2x? 2x plus 3y. 2x plus 3y equals 12. So this is what we have for number 1. We are given this equation. So if you go into Desmos, you can actually tap. If you tap on the x-intercept on the graph, it will pop up a gray point. And if I tap on the x-intercept one more time, it'll give me that point, 6, 0. And if I tap on the y-intercept, it also gives me that, which is 0, 4. Well, that's exactly what I got, right? I got 6, 0 and 0, 4. So I did this correctly. So if you ever want to check yourself, you can always use Desmos. Okay, again, the first thing I always want to do is I want to create a balanced workspace so I can do x-intercept on one side and y-intercept on the other side. For the x-intercept, I'm going to solve it on the left, and that's going to be number, 0, or blank, 0. I'm looking for what that blank is supposed to be. And I copy down the equation that I had at the beginning. 5x plus 3y equals 15. Well, what do I do next? Well, I want to plug in a 0, but where do I plug it in? I'm going to plug it in for the y value, because an x-intercept always has a 0 for the y value. And when I plug in, I always use parentheses. You always do that because you'll cause the least amount of mistakes that way. So then 3 times 0 is 0. So I have 5x equals 15. Divide both sides by 5, and I get x equals 3. What's my x-intercept then? 3, 0. Okay. Now I'm going to solve for my y-intercept. So I'm going to go a little bit faster because hopefully we're getting the hang of things. Okay. Copy my equation from the very beginning. I'm going to plug in a 0 for my x value because an x or y-intercept always has a 0 in for the x value. Okay, 5 times 0 is just 0. So then I have 3y equals 15. Divide both sides by 3. And I get y equals 5. And my y-intercept then would be 0, 5. How do I know it looks like that? Because I know the form that it's 0, blank. The only way to mess this up is if you forget what an x-intercept looks like and what a y-intercept looks like. Okay, but the easy way to remember that is you're solving for x for an x-intercept and you're solving for y for a y-intercept. Now on the next page, we have 3 problems left, so we're almost done. With number 3 and 4, these equations look a little bit different from the previous page. On the previous page, my x and y were on the left side, on the same side, but on number 3 and 4, my y is on one side and my x is on the other side. However, you do still solve the same way. You're still substituting in a 0 each time you're doing this. So let me go ahead and split my workspace down the middle for both of these. I'll go ahead and do both problems and split those down. Okay. Now on the right, I like to look for my x, or my left, I like to look for my x-intercept, and I know that's going to be blank, 0. I'm going to do the same thing over here. And I know on the left or the right side, I'm going to do the y-intercept on that workspace. So 0, comma blank. Okay, so I know it's going to be 0, comma blank. Now I'm going to solve the left side first, number 3. Y equals 3x minus 3. Let me go ahead and copy that down just like I did with the other ones. Okay, now this time it looks a little bit different, but you still do the same thing. So you know that an x-intercept has a 0 in for the y value. So you're still going to plug in a 0 for y. Well, if I plug in a 0 for y, it's now just 0, and then it'll be equals 3x minus 3. Right, now I have a 0 in for the y value. And now I'm going to get x by itself. So I'm going to now add 3 to both sides. Get rid of that, because negative 3 plus 3 is 0. 0 plus 3 is just 3, so I have 3 equals 3x. And I want to get x by itself, so I'm going to divide both sides by 3. 3 divided by 3 is 1, so I just have x, and 3 divided by 3 is 1 over here. So what is my x-intercept? It is 1, comma 0. So again, you're doing the same thing, the equation just looks a little bit different. And I'm going to copy down the equation on the other side as well. This time I'm going to plug in a 0 for the x value because the y-intercept has a 0 for the x value. So 3 times 0 for the x value minus 3. Well, 3 times 0 is just 0, so I have y equals negative 3. Oh, it's already done. So now my y-intercept is going to be 0, comma negative 3. So see, it's not too bad. It's just, you just have to think about it and be like, oh, I'm doing the same exact thing. It just looks a little bit different. All right, so let's do some more practice over here. Y equals 2x plus 7. Now here I'm plugging a 0 in for my y value because I'm looking for the x-intercept. So 0 equals 2x plus 7. I want to get x by itself, so I subtract 7 on both sides. So 0 minus 7 is negative 7 equals 2x. And then I divide both sides by 2. And then I get x equals negative 7 over 2, or you can get x equals negative 3.5. The only time you're allowed to write a decimal is if it's a neat ending decimal. If it's a repeating decimal, you have to put a fraction. So your x-intercept could either be negative 7 over 2, comma 0, or negative 3.5, comma 0. So if you want to write it as a decimal or a fraction here, that is acceptable only because it's not repeating. On the other side, I have y equals 2x plus 7. I'm going to be plugging in a 0 for what? For the x value. So I know I'm going to plug in a 0 there. 2 times 0 is 0. Then I have y equals 7. So my y-intercept is 0, comma 7. So again, not too bad, right? We have our answers. Not too bad. It's the same exact thing. The equation just looks different. All right, our very last example here is a word problem. And it's because you will see word problems and you will be asked to find the x and y intercept of those word problems. You borrow $1,800 from your parents. To repay your debt, you give them $150 per month. Write an equation to model the situation. Calculate the x and y intercepts and explain their meaning. So first we got to figure out the equation, right? Well, what do we know? Every equation, first of all, has an equal sign. So we're going to have an independent and a dependent variable. Every equation has x and y. Well, I know that I'm going to borrow $1,800 from my parents. So I know for a fact that it's going to start y equals, and I'm borrowing $1,800 from there. So I start off and I borrow $1,800. That's what I start with. I start off with a balance that I owe of $1,800. But I'm going to be repaying them back each month, and I'm repaying them $150 per month. So as I'm repaying them back, my money that I owe them is getting less and less. And every time I do it, I'm doing it per month. So it's going to be minus 150x because you're doing it each month. So what do you think the x would represent? The x would represent the months, right? Because every month I'm giving 150 back to them, and then I owe them less and less money. Well, the more I give them back each month, the less money I owe. So y is going to be, I don't know why I changed colors. Give me 1 second. Y is going to be money owed, right? So after like 2 months, you owe them less money. So your y is depending on how many months you have repaid money back. So now we have an equation. Then it says to calculate the x and y intercepts and explain their meaning. So again, I'm going to split my workspace down the middle. I'm going to find my x-intercept first. X-intercept is blank, comma, 0. Oh, just kidding. Oh, yes, it is. Blank, comma, 0. Freaked out for a little bit. So I have my equation. Let me go ahead and write that again. Okay, I have my equation here. And here I know that I'm going to plug in a 0 for my y value because an x-intercept has a 0 for y. So I have a 0, and then I have equals 1,800 minus 150x. Well, I want to get the x by itself, so I can go ahead and subtract 1,800 on both sides. Or you could add 150x to the other side as well. There's lots of ways to solve an equation. 0 minus 1,800 is negative 1,800 equals negative 150x. I'm going to divide these both by negative 150. So I have x equals negative 1,800 divided by negative 150 is 12. So is that what an x-intercept looks like? No, right? We want to write it as a point. So the point here is 12, 0. Then the problem wants me to explain the meaning for this. So what does my point represent? A point is x, y. Well, what is x in this problem? X in this problem is my months, right? Sorry, changing colors. X is my months. So if I have a 12 in for the x value, it means at 12 months, right? It's saying 12 months. What does a 0 represent? That's my y value. That's how much money I owe. So at 12 months, I owe $0. That's what that means. That's what the x-intercept means. Now I'm going to solve for the y-intercept. I'm going to have to copy down the equation. So I have this equation. So the hardest part for this one was just coming up with the equation, and then we'll have to interpret the meaning. Okay, for an x or for a y-intercept, it's going to be 0, number, so 0, blank, because we're solving for the y value. We know that our x value is going to be 0 because our y-intercept always has a 0 for the x value. So I'm going to copy down everything exactly how it is, but I want to make sure I plug in a 0 for the x. Well, negative 150 times 0 is just 0. So y equals 1,800. So my y-intercept is 0, 1,800. Okay, now we got to interpret the meaning. The meaning for this is, well, what does the x value represent? It represents the month. So at 0 months, and then what's the y value represent? The money owed. So at 0 months, I owe 1,800. So at the very beginning, before I have paid anything off, I still owe $1,800. And that makes sense to me. All right, that is x and y intercepts. So again, we've learned how to identify them off of a graph, off of a table, solve for them with equations, and then also interpret a word problem with it. If you have any questions, please feel free to contact me and let me know.